This is the pre-lab video for Lab 6, Just Beat It, a binomial experiment. Read the lab manual before you come to lab, so read pages 43 through 40. The materials you need to remember from lecture to do this lab are what we learned about the binomial experiment. This experiment is going to be set up as a binomial, so you can use the formulas of the binomial to answer some of the questions at the end of the lab. Remember that in order for an experiment to be a binomial, we need the following to be true. You need a fixed number of independent trials. You need to know what n is. For this experiment, we're going to assume that the trials are independent of each other. The fixed number will be assumed to be the total number of students when the class data is compiled. The second characteristic of a binomial is you need only two possible outcomes, a success and a failure. In this experiment, a success would be if a person is able to move all the beads on the skewer in at most 3 attempts. A failure would be a person who is not able to move all the beads on the skewer in 3 different attempts. Don't worry, it doesn't matter if you succeed or fail at the experiment. That has nothing to do with what will happen with the lab. The last characteristic of a binomial is you need a constant probability of success. You must know what P is. In this experiment, based on what the lab manual says, we're going to assume the probability of succeeding is 80%. So for our experiment, we have a binomial because we're going to assume the trials are independent. We will have a fixed number of trials based on how many students are in the class. We have 2 possible outcomes. Either the student was able to move the beads in 3 attempts or was not. And we have a constant probability of success, which we're going to let equal 80%. Once you know something is a binomial experiment, then you can use the following formulas. You can find the mean of the binomial experiment by taking n times p. You can find the standard deviation by taking the square root of n times p times 1 minus p. You can also find the probability of a particular number of successes by using this formula. X would be the particular number of successes. For this lab, the value of n could be large depending on how many students are in your lab room, which could create some issues for the calculators if you try to find the combination n factorial over x factorial times n minus x factorial. In other words, this formula could give you a message as overflow, meaning the number is too large for the calculator if you're trying to find the combination part. So if you get an error message, don't worry. You can use software to calculate the probability of any value of x. You could still set up the equation by hand, though, to show you correctly now how to identify x, n, and p. You can use StatCrunch to find the probability of a binomial experiment. To do this, log into StatCrunch and open a StatCrunch spreadsheet. You don't need any data in the spreadsheet. Just select Stat, then go to Calculator, and then select Binomial. When you do that, a screen like this will open. At the bottom of the pop-up box, you can change the values of n and p and set up the correct inequality you're trying to solve at the bottom. So put in what n, p, and set up your inequality of what you're trying to find the probability of. So let's assume n equal to 100 and p is 0.7. Find the probability of exactly 80 successes. So we can set this up by letting n equal 100, p is 0.7, and I set my inequality to equals 80, and it will give me the answer I'm looking for. Make sure you know how to do this using a calculator for smaller values of n, p, and x, because you will not have access to StatCrunch for your exams. Don't forget you must completely turn in filled in tables and figures from pages 48 and 49 in addition to the questions at the end of the lab in order to get full credit. You also need to take your pre-lab quiz at this time.